Hi everyone, this is Tom Cherryholmes with the next video in the Amiga PAC-MAN series. This one goes over the creation of the Clyde Blitter object. Recall that in the previous video I talked about that we will need, because of the limited number of hardware sprites that we will be able to use, we need to use the sprites for PAC-MAN and 3 of the ghosts, but the 4th ghost needs to be implemented as a Blitter object. And this video shows how we will be implementing that Blitter object using the Bob section of the GELs subsystem. To start off with, we're really going to be using, we're taking, like we've done with everything else in the past, we're taking an existing test harness. We've renamed it, moved it over, done all the little housekeeping and bits and pieces, and we're starting off with this. And we're going to wind up creating, go to my workspace folder, to my other copy of GelBob that's finished. And this is essentially what we'll be creating. We'll be moving the Blitter object over across the playfield with the GEL system doing all of the backing store saving that's required. When I did this demonstration initially, I used Blinky as my Blitter object. But since I went ahead and did Clyde, we'll actually be using Clyde's colors for this moving forward. We'll make that change as we start building the code. So how do we start? Well, like we always have with all the other videos, we open up our little test harness here and we start to work. And let's actually make sure, that I am opening up the right one here. Got multiple ones here. And we have GelBob here. GelBob, since it uses the GEL system, of course we need the graphics routines, but we also need graphics GELs. And this will give us all of the data structures that we need to create GELs, or graphic elements that the operating system can help us move around. For reference, as always, the ROM kernel manual helps us out. In the chapter in animation, there's a section called Using Bobs, and it actually comes after the section for using VSprites. I will be making a side video on VSprites. I ultimately decided not to use them because I didn't need to use them, but VSprites are virtual sprites. So it uses the GEL subsystem to take and multiplex the use of sprites so that you can have more than 8 of them on screen at one time. But since the GEL system is a layered subsystem, Amiga decided to take and use some of the existing data structures that are used for VSprites to also encapsulate data that's used for Blitter objects, or Bobs as we see them called here. You'll see that the first thing that we need to do is we need to define our Blitter object here, as we have with everything else. We'll start by making a structure, a Blitter object structure, a Bob structure, called Clyde Bob. But the Bob structure also is connected to a corresponding VSprite structure. So we need to define that too. Furthermore, when we actually get moving, we need to take and connect these two together. As you can see right here, we need to do these two sections in our program code. So moving on, these structures need a couple of things in order to function. One of the things that we actually do need is a copy of the graphics that we're going to use. And since we're doing this not as a sprite, we're doing it as a Blitter object, this is the same as basically drawing something onto the playfield. So the graphics are laid out in exactly the same way. If you've seen how I handle intuition images, this is literally how we're going to be handling laying out the data for the Blitter object as well. And for that, we need to open up one of my other projects here to pull in some Bob data. Give me a moment. Oop, and I think I accidentally have opened it twice here. Okay, so we have visit file here. And we'll go to workspace real quick. Go to PAC-MAN. And we will pull in Sprites and Bob right here. And you'll see that we have Sprites.h and Bobs.h. Well, we might as well just make a duplicate of that, sure. And we'll pull that into our workspace here that we're currently working on as soon as it's finished. Scoot over just a little bit, move this in, and rename it. Bobs.h. These are our Blitter objects. It contains other bits and pieces here too, but the one that we're really interested in, if we take a look at it and see what it is, we have our shadow mask for Clyde for both animation frames, and we have our bitplaned bitmap for Clyde, split into these three sections. Well, what do these three bitplanes actually represent? Well, we can go take a quick look. Excuse me. Move out of the way there. To make sure I'm actually in the right file here, because I was moving around and I accidentally opened up 2 copies of Emacs. I just want to make sure. Yes, there we are. Okay. Just wanted to make sure that we were in the right file. Let's move on. First thing we need to do, actually, is add an include to our Bob's include here so we can use it. Then we have access to those data structures. Let's take a look at them. Let's come all the way down to the bottom, because we'll deal with the shadow mask here in just a second. But what we have right here is a bitmap for Clyde. And it's laid out the same way as an intuition image or a bitplaned image, where the first bitplane is laid out in its entirety, then the next bitplane, and then the next bitplane. We need 4 of them. What does this look like? Well, let's have a look. I made a little learning aid here so we can actually take a good look at this. We'll take and quit this real quick because I really didn't want to, yeah. Make sure, okay, great. Now, if we go to my workspace here, this is actually up on the GitHub so you can see it. There's a test harness called Ghosts. And if we open it up, we can see how the bitplanes for Clyde are actually split up. And you can see that bitplane 0, 1, 2, and 3, which corresponds to colors 1, 2, 4, and 8. You add the colors together to get the final color value. So you can see all the bits and pieces of a bitplane here so that we can build 2 of Clyde's frames here. And that corresponds entirely to this. So we've got the bitplanes, we got the bitmap, everything's good there. Now we can continue back to where we were. Oop. Yes, exit, please. I'm going in 15 different directions here. I hope I saved that. If not, we'll just take and pause real quick and put it all back the way it was. Yes, I'm doing these things live, fellas. It's kind of silly, but there we go. Oop, no, I have to go ahead again. Include Bobs.h, okay. And of course we need our data structures for our VSprite and our Bob. And we have our bitmaps. Now with our bitmaps in place, we need one more bit of memory, which we can go ahead and statically allocate here. And this is what is called our save buffer. Telemarketer calls. Love them, don't you? And you need just as many bytes as you need in here to take and save all four bit planes of what you're saving against here. In this case, we need 512 bytes. It's a 16 by 16, so multiply that 16 by 16 by 16 by 16 by 3, and you get... Oops, that's in hexadecimal, fellas. Excuse me. I'm making all sorts of crazy mistakes today. 768. So, yeah, actually, yeah, let's go ahead and increase that. So, make sure that you have enough of a save buffer to handle the pixels that need to be shoved into this buffer here, because the gel will be using that as a temporary backing store to restore the background if the object gets moved. And you need one of these for each gel that you implement. So it's just a linear buffer. So with that, now we're going to take and implement this going down a little bit. We have a, actually, excuse me a second. We have create task. I need to make a task for Clyde. Okay. Let's go ahead and come down into main and spin off our task. Go ahead and spin it off, because we're going to be doing everything inside that task. It's Clyde task, and 1 second, make sure that my parameters are correct. Oh yeah, I need to add the priority beforehand. So priority 1, priority 0, priority 1. You can put up to 127 here, and if the task is small enough, this guarantees that your task will run without being preempted. In our case, we're going to give it equal time with everything else, and it's going to point to our Clyde task here, and we're going to give it a stack of 1,000 bytes or so. Okay, great. And in the meantime, it's going to take and delay, give us long enough for us to run our task. Cool. So there we are. Void Clyde task. Bam, bam, boom, boom, and here we go. Well, what goes inside this Clyde task? Well, what do we need? Let's take a look. If we actually take and do a little bit of finagling here, the first thing that we actually need to do is we need to initialize the GELs subsystem. We can see that. Let's go ahead and look for init GELs real quick. We see it in the example program here. One moment, let me actually find where it actually references this in the reference itself. Okay, here we go. My PDF viewer, this PDF viewer searches from the back to the front, which is just interesting to say the least. But if we go back and look here, Chapter 3 Animation in the ROM kernel manual for libraries and devices, it starts talking about the different types of animation, but it talks about the graphical element system that needs to be initialized as well. So we need to actually take and initialize our GEL system before we can use it. In order order to do that, we need to take and provide this function init GELs with 3 bits of information. We need to give it a head, which is the start of the list. We need to give it a tail, which is the end of the list. And we need to give it a pointer to a GELs info structure, which it will take and modify as the graphical element system is used. It tells you right here that you need to use 2 dummy VSprites as placeholders for both the head and the tail. So you just take and implement them here. And the best way to do that, if you take and dig through a bit more, you'll find that implementing that is easy enough. You just need to take and create two dummy sprites. And since we're defining these in global here, it's going to take and zero them out, and zeros are all it cares about anyway, so we're good here. So all we really need to do now, and we need a GEL info. And again, that's much the same thing. So all we really need here is another structure. GELs info. Now we can take and do our call to init GELs, pointing to the 3 structures that we just defined and initialized. At this point, GELs is almost ready to use. The one part that isn't immediately evident in this documentation here that I had to take and remember and pull back and realize, oh yes, this is only the first part of it. You have to initialize the data structures, but you also have to attach those data structures to a RastPort. It doesn't matter if you attach it to a screen RastPort or to a window RastPort. You have to give it somewhere where the GELs will actually draw. And this is especially important for Blitter Objects. In our case, we can literally do that by doing this. Calling WPAC-MAN our port. And looking at GELs info. And pointing our data structure, attaching that data structure that just got created by init GELs into the RastPort, which means that the extent of where the graphical element system works is in this window on this screen. Okay? Now we can actually start doing some interesting things. If we come back past all the simple sprite, all the VSprite stuff here, come back to Bobs, using Bobs, we need to do a couple of other things here. The first thing we need to do is we need to attach Clyde Bob to Clyde VSprite and vice versa. There is a data structure field called Bob VSprite inside of struct Bob, which gives you the ability to take and point that over. So we can point that to Clyde VSprite. And vice versa. We need to make sure that those two things are connected so that the GEL subsystem can grab whatever bits and pieces of information that it needs as it's going through these data structures. Now we need to go ahead and set a few elements. The first thing we need to do is we need to specify the height of our Bob. But we do this inside the VSprite. And you can see it right here. Specifying the size of a bob, we go, there's a height field, and since our data is 16 lines long, its height is 16. The width is also 16 pixels. However, you specify this as the number of words that this bob is going to take up, round it up to the next word. 16. So we need 2 words. Oh, so that's we need 1 word here. Sorry. Yes. 16. So we only need 1 word to store the data. We need to specify the depth of this sprite. Well, this particular sprite needs we'll say 4 colors here. So 16 colors. And we'll set our plane pick to use all, to enable all of the planes. We need 4 of them, so yeah, 4 bits, 16 bits. Okay, there. So now we need to also specify sorry, I'm doing that out of habit. We need to specify the pointer to the image data. And to start off with, that image data is going to correspond. We'll go ahead and just open up Bobs.h here so we can see. So we'll say, R0, we'll start with R00 here. So bitplane 0, bitplane 1, bitplane 2, bitplane 3. All of these bitplanes are used, so the depth is 4, of course. And it needs to point to BM Clyde R00. Okay? Keyboard focus. Where did I type that? Oops. So the image data needs to point to BM Clyde R00. That's BM Clyde facing right frame 0. Okay? Furthermore, now we actually need to specify something specific to the Blitter object. And Blitter objects, unlike VSprites, unlike sprites, it needs what is called a shadow mask. What is a shadow mask? Well, we can see it down here. A shadow mask is literally a pointer to a memory area, which is the combination, logical combination of all 1 bits of a Bob image. This is used ultimately to determine what pixels are transparent and which pixels are not. So if we look, go ahead. That's SM Clyde R00, and if we take a look real quick at it, excuse me, we'll see that it is as if I took all the 1 bits on the image and then smashed them all together so that we know which parts of the image are opaque, which parts of the image are transparent. Iterated on in the same way that we did for the sprites, just in a slightly different order. So there's only, shadow masks only are 1 bit plane deep, so it's just a single bit plane saying which pixels are transparent, which ones aren't. I hope that makes sense. So now we have our image data and our image shadow. At which point, now we can take and start putting in our coordinates. VSprite X. Let's say we'll start here. Sure, why not? These specify our X and our Y coordinates. And we also have Clyde Bob save buffer. Remember that save buffer that we created earlier? Let me make sure I called it Clyde save buffer. Oops, sorry. You can tell I'm definitely on autopilot here. We'll save the file just for good measure. So that the gel system can have a buffer for a backing store. We're good to go there. And we have flags, and we're going to go ahead and set the same thing to both of these, but we want to save the background. Oops, don't do that. It's always interesting to try and get the slash right. Oops. So give me a moment here, guys. I apologize. I'm away from this for more than a couple of days, and I literally forget how to type the backslash and the brace key. There we are. Sorry about that, fellas. Just had a momentary brain fart. Okay, so save back. So we can save the background, and we want to overlay the Blitter object over what is already on the background. If we don't do this, then what will literally happen is that the Blitter object will literally take and obliterate whatever it's placed on. It's faster, but it doesn't take what's already drawn there into account. It's like sort of like doing an exclusive OR, but with the shadow mask, basically preventing bleed through. Anyway, so same thing. Here we go. Those two bits and pieces are there. We're ready to go. We have our initialized bits and pieces. Yay! Everything's attached. And now that we've got our Blitter object attached, all we have to do to add it into the animation system so that it will use it is to use the add Bob call. Add Bob has two parameters. A pointer to the Bob we created. Since it already has pointers to the VSprite as part of its structure, we don't have to do an add VSprite. The gel system already knows that this is a Blitter object, but it will go into the VSprite structure to grab common elements for other things that it needs, like the height, width, depth, that sort of thing. But we also need to point in to our RastPort, because our RastPort contains the pointer to the gels info. So, bam, there we go. We've added our Bob, and at this point, since we only really have one particular element, well, here I'll do it this way. So this particular section of the manual goes through what we just did here, setting up the individual VSprite and Bob bits and pieces, showing you how colors are selected based on binary combinations. If you use sprite collision, if you're going to use the collision detection routines in the animation system, then you can set up the collisions and the masks for those. We're not going to, so I'm not going to bother with it. Finally, it says, okay, this is how you define parameters, coordinates for parameters, everything you need here. It goes into a discussion on how you can specify if you've got two Blitter objects that overlap each other, which one takes priority over the other. You can choose to let the system decide the priorities by basically saying, well, you can set before and after pointers and the Bob data structure to 0, or you can explicitly set these priorities to say that I want to draw Bob 2 before Bob 1, Bob 1 before Bob 3, and so on. You have very fine-grained control over how you want this to work, and it goes into great detail on how all of this actually works. Finally, you saw right here, yes, saving the playfield display, making the image buffers properly, etc. Bob flags, VSprite, save back, overlay, what all of these different flags actually do, and how to read them. Okay, great. Finally, we got here. So init GELs, okay, add our Bob. And at any time when you're done with a particular Bob, you can use remBob to remove it from the playfield. And if you want to remove it absolutely immediately before waiting for the next animation call, you can do it remiBob. So the next thing that we have to do, we have to take and sort the data structures for all of these Blitter objects and VSprites in the correct order so that the animation system can just iterate through them linearly to take and draw them. For that, we use sortGList. And all we have to do here is pass it into a pointer to our RastPort. Because again, that is the GELs info that this needs in order to function is part of that, is now we attached it to that RastPort, so it's just there. At which point, we can then pretty much draw the GList. It takes a couple of parameters, notably the RastPort and the viewport for the screen that we're attached to. And we can wait for the top of the frame. So now we've got this right here. We've created our task. Let's make sure. Let's make sure down here at the bottom, as before, that we properly get rid of our task. And if everything goes as it's supposed to, we're now at the 33-minute mark. Okay, that's about good. Now we'll do our first compile to see how this turns out. We should just have Clyde here on screen by his lonesome. Let's see how this works. Hopefully I didn't make any typos here, but with my luck today, yeah, you never know. Seriously, it's been so weird going back through and remembering all of the weird little edge cases that you have to deal with, because the way that the GEL system, there are common elements for both Blitter objects and virtual sprites, but internally the system handles them very differently. And because of that, there are a number of behavioral edge cases between the two. Ooh, wow, we actually got an internal compiler error because of that one. So let's start digging through and fixing some of the typos here. Oh my gosh. Okay, first one's at line 112. All right, Clyde task. Okay, void Clyde task. Why are you mad at me with this one? External attribute item attribute mismatch. Did I define this probably, because yeah. Let's do that. So let's do that. And let's see if, let's go down here to create task and let's come all the way down here. That's task. Okay, great. Create task. And this becomes Clyde task. Okay. Did I accidentally make? Yeah, I did. Oops. So that just needs to be task. Or make sure that my call to private. Okay. Yeah. That was me being an idiot. So let me see if some of the others here. 127, fine, that's okay. 133 needs to be fixed real quick. That needs to be okay. And then invalid structure reference 3334. So that's the same thing. So the compiler's just hitting me twice there. So yeah. The CX error right there was basically the compiler getting turned upside down and sideways because I mistakenly referred to struct task as a function pointer in and of itself. Oops. Yes, that's an accomplishment, getting an internal compiler error. I really hope you guys are enjoying this and getting some good information out of this. I'm be very surprised if any of you are actually following along and doing this. I really wouldn't recommend anybody actually writing software in this exact environment that I'm actually using, but shit, I never know. This particular warning, this shouldn't be a problem. I mean, we can go take a look at it real quick while it's building, but we should be okay. Okay, so whatever. I think we fixed that by basically just changing how this is set up here. So save buffer, and PAC save buffer. I didn't like that word. Yeah. Okay, I don't think it's going to be inconsequential anyway. And yes, that save buffer needs to be as large as the number of bit planes for the target screen of the RastPort that you're dealing with here. We're dealing with a 16 color display, so oh yeah. And a function, I called it, yeah, oops. Make sure your functions are, have the proper case. Let's try that one more time. Oh boy. Fun, isn't it? Not editing any of this out. This is how long it took. This is how long for you to figure out where the bugs were. This is how long it took for you to compile, to find the next bug, and so on, and so on, and so on. It's okay though. This warning here, warning 30, which is very common with early versions of Lattice, is just a fancy way of saying, well, the pointer that you gave me is of a different type than the one that I'm expecting. Casting to the appropriate type is what usually fixes that issue. The irony here is that most of these pointer types are all the same type anyway. They're all 4 bytes long, so it really doesn't matter. It just, you know, if you want to get rid of the warning, then you can cast to the appropriate type. So if everything's going as it should, and we'll see how good my luck is here, we'll run GELBob, and there we can see Clyde being rendered to the display. And Clyde's colors are a little off. But we can fix that here in can we just go ahead? Let's see if we can just go ahead and fix it. Yeah. We'll munge the palette real quick just to fix it so that the next compile that we do, it'll have the right colors. So we're looking at light red. Look for that green. We're looking for that green, that light green. That actually needs to be... So we've got some light greens that are happening here. 0, F0, F0. So let me take 1 second here and let me get the right colors for the palette. Okay, so first thing we're going to do is we're going to change this green here to a blue. And yes, we're winding up with some duplicated colors, but that's fine. The next thing we're going to do is we're going to change that that brown color that is FA0, and we're going to change that to a pale orange. Yes, and that's going to match up with this, but meh, whatever. We'll go ahead and save that, and let's continue on. So now that we've drawn this, let's go ahead and just scoot it across the screen real quick. That's easy enough. We just wrap this in a for loop. So the first thing that we ultimately do is we just change the X value. That's pretty easy. We don't have to work too hard for that to happen. So all we need to do, let me scoot down to Clyde task real quick so I can get this right. Just change Clyde VSprite, the X position. And since we're under control of that variable, it's not just a write-only register, we can just do that. Let's just do that. ++. Another optimization that we can do, because we're not changing, because we only have one Bob in our gel list here, and we're not going to be altering the position of how this is going to work. We can take this and take this sort function, which does take a good chunk of time, and optimize it out by only doing it once. There are only certain cases in which you can actually do this. This just happens to be one of them. We have one Blitter object that needs to be affected in this manner. So we can just do the sort once, get it in the right, get everything in the right order, and just all we need to do is change the Clyde VSprite, draw the GList out again, and then wait for the TOF. Because we've specified save back and overlay, the gel system will automatically do all the necessary work to take and do all of the background saving. Because again, this is a Blitter object. It's using the play field. So if we now take that and save that real quick. Go ahead and do that. Celsius energy drinks. Love them. They're a good source of vitamin B for sure. Me being an idiot, I'm gonna go ahead and forgot to define my variable. In I0, let's go ahead and make one for frame 2 because we're going to use that in just a second. So essentially what we're doing here is what's specified here in the next section of this chapter, changing the bobs. And it gives you the list of ways that you can take and change the characteristics of the bob. You can change their appearance by changing the pointers to the image data in the VSprite structure. And since, it's using the same image shadow here, and init masks do all of this stuff, and it's showing you changing the XY value to change where it's being put in the drawing areas, changing object priorities so you can put objects in front of or behind each other, and so on, and so on, and so on. Yes, I know, no reference to identifier frame. We'll rectify that one in the next pass. Finally, there is one aspect here. There is provision inside the GEL system for double buffering. It shows you all the bits and pieces that you need to take and enable or disable the debuffer flag, but it gives you also the tricks that you need in order to take and implement double buffering. You need to implement a debuff packet structure. You need to take and attach it to your bob, and set the flags for, I'll set these variables, set the flag, and then the Blitter object will be double buffered by the GEL subsystem. In our case, we have enough time, we don't need it. So we'll go ahead, we're in GEL Bob, and there's Clyde moving across the screen. Now with the correct colors here. So with that, now we can take and move to the next thing here. Okay, groovy, right? Let's take and for our final act here, we'll take and make him use both animation frames, timing them out appropriately. And for that, we need to set up a couple of things. So we have our loop as before, and we specify if I, we only want to do this every few frames, so we just change which frame is actually going to be displayed. It's going to take and alternate between frame 0 and frame 1. Okay, so the next thing that we do, just as we changed Clyde VSprite image data frame, which frame we're going to use? Okay, BM Clyde R00, otherwise BM Clyde R01, Clyde Bob. Since Bobs have image shadows, we also need to update the image shadow. So there we go. We'll take and pretty that up just a little bit. So now, in addition to setting our X and Y values, we have this right here. Okay. X gets moved. Okay, great. We're just going to take and increment that across. Fine, whatever. Again, we draw a GList. Once we've got everything set up, we draw our GList. We wait for the top of frame. Robert's your father's brother. This should be everything we need in order to take and animate this. Write it out. And execute, which hopefully this should be our last compile for this video. Fingers crossed. Looking good? Yes, we know. We should be just about done with, okay, there's the end of the first pass. The second pass is always very quick, because all it's doing here, the pass 1 did all the hard work, spitting out the intermediate bytecode, and then it just serializes it into the object file, and then we quickly take and use Atom to take and say that this needs to go into chip memory for now, and then we just link it together to form our final executable. And yeah, I know some of you might be thinking, we're focusing on the graphical elements and everything, and yeah, that's kind of the point here. We will be dealing with logic. We will be dealing with game logic in later videos. But you can see right there, there's our Bob bobbing along, animating and animating and animating. Here we go. And that's pretty much it. So what's coming up in the later videos? Well, if we go over to our workspace here, we can kind of take a look. Our next video, the next video in the series, is going to be called Sprites and Bob. And it literally involves taking the Pac-Man sprite that we developed earlier, adding the tasks for the 3 other sprites, for the 3 ghosts, and the Bob, all on screen at the same time to produce this. All of the sprites working together in harmony. Sprites and the Bobs working together in harmony. So there we go. Also, we'll be talking about how things like the menu system works. So we'll show you how flexible Intuition's menu system actually is. So you can see, for example, the fact that we've got these menus here with the arcade fonts and everything, so you can select certain things, but you'll have image menus, so you can select your starting stage as well. So this is how this will be implemented. You can see Intuition's menu system is extremely flexible in this regard. We'll also be talking about how we're going to be rendering out pellets, and we're going to start talking about how we're going to be reconciling the tile-based display that Pac-Man uses internally for collision detection and the like, and how we do things like render out our dots, render out our energy pellets, etc. Get everything reconciled and start working on the first bits of our game logic. So with that, I hope you guys have enjoyed this. Like, share, and subscribe if you can. Tell everybody you can about this. Maybe some other people will be interested in this. I'm going to keep these ad-free as promised. And until next time, guys, have fun.